This has been a day which has been in the making for a while.
We have SDK in JavaScript, and we are building new domain-specific interactions. So we will be able to provide like one-liners for almost everything you can do in MOI.
At the heart of everything we do at MOI is the participant, is the community. And I'm really excited to announce that we have plans in place to get the community involved in multiple different aspects.
So, hi everyone. Firstly, welcome to the MOI Beta Mainnet launch. It's really exciting to have you all here to enjoy and congratulate us on this big milestone. I'm so sorry because it's too loud in here because I'm here at the Token 2049 main stage. I'll show you around 1 second. So I'm at the main stage and the Token 2049 just wrapped up and the energy has been exciting. The event has been crazy till now. It's been 3 days we are here. The MOI team is here on the ground. Ananta sir, Sujata ma'am, Aditya, the dev role. So it's been really awesome till now. And yeah, it's just a milestone, but a very big for us because we have been developing and putting our all hard efforts to building this protocol. And here I'm excited to welcome you all and onboard you to MOI. So yeah, on to you, Ruta. I just want you to showcase the recap video we have made till now. So yeah.
Yes, absolutely. Good morning, good afternoon, good evening all. I know we are across several time zones today. Today is a very exciting day that we get to launch our BetaNet. This is really important for, all our DevRel people, all our developers, this is a really big milestone for the entire community. We want to keep this short and simple because for those of you in Singapore, we know that the day is just wrapped up and, the best is yet to come. And it's probably about 4 o'clock in India. So, Thursday evening. And last but not least, it is bright and early at 6:30 in Eastern Standard Time. So, to get started with your day. So let me start sharing my screen and then we can have AK kick off our call.
All right. Thank you, Ruta. Thanks, everyone, for being here. So this has been a day which has been in the making for a while. So I would like to congratulate the development team for working so hard to make this beta mainnet launch happen. So what I'm going to try to do is over the next 5 minutes or so, give you the inspiration behind why we do what we do here and what sort of value that this technology can provide to the decentralized world. So what is the motivation for us doing this technology? I'm sure many of you might have heard this from me before for the umpteenth time. I think the big shift that we foresaw about 7 years back was the world moved into a digitally interacting world. It's not, technology has been with us for a very long time. Initially, it was just automation, then it was supporting, and now we are starting to live through it. I'm sure many of you ordered your food through Grubhub today. Many of you took Ubers. So it's not just about communication. We are not just connected by technology, but we are living through it. But the problem today is today's technology is built for automation and connectivity, right? We can send emails, we can talk to people, and it's a very big, gigantic tool and a very good one at that. So the technology fundamentally focuses on 3 attributes today. What we have built, what the internet of today is, where the instructions get processed, what the instruction processes it on, and how it gets processed. So it's a huge, big machine which processes information. So that's the status of technology today. But in this new digitally interacting world, it's not about information. It's about value transfer between participants. So either I transfer a token, or I hire a cab, or I order a food, or I sell my asset, register my land. It's all about value transfer between participants. And so there's a fundamental difference. Information can exist in both places. So if I send you a piece of email, I can hold on to that email. Nothing changes. But if I transfer you money, I can't hold on to that money. So that piece of information needs to transfer to you. That value needs to transfer to you. So it's not just information flowing through pipes. It's about value transfer between participants. This is the new need. So when this new need, why do you need another L1? So if there is this new need, the first question people ask is, there are many layer one protocols, many infrastructures. Why do you need another one? Fundamentally, that is because today's technology and today's blockchains focus on managing information and not transferring value. They are optimizing the wrong problem. And we'll tell you what that problem is. And that's the fundamental challenge that we have, or a design solution that we have brought in that would solve many of the underlying problems. So today's blockchains are not built for value transfer. They are built for data replication. What I mean by that is a network has got a bunch of nodes, and the fundamental purpose of today's blockchains is to make sure the data is replicated all over the network. And so the same data needs to exist in every node, and that's the purpose. And what that means is every node needs to see the data in the same order, and which creates fundamental problems. So what they call as in blockchain is the trilemma is a symptom of this problem, not really the disease. So the fact that today's blockchains focus on data replication, not on value transfer, forces everything into a globally ordered model, which creates all the fundamental limitations. So how do we solve this? So we have created a fundamentally new computing paradigm called contextual compute. It introduces the who, or the participant, into computation. So previously it was where, what, and how. Now we introduce something called who. So this new dimension of participant, who fundamentally alters the landscape. In today's model, assets and intelligence, your values, all of them are stuck to an application or a smart contract. But in this new model, they all move to the networks. They are not the apps, through the participants. Say, for example, in today's situation, if there is an agent who's working on a booking app, and the same agent then goes to an account management app, the context of what was done in the first app is not available in the next app, because all intelligence is stuck in the apps. In the new model, because we move everything to the network through participants, the context is available for each interaction. So the networks moves from dumb pipes to thinking networks. So with contextual compute and with participant-centric design, networks become intelligent. So how does this solve the problem? So previously I told you in today's model, in the model of information transfers, everything is ordered at a global level. The network being consistent was the fundamental need. But in real world, value transfers happen in contextual causal boundaries. For example, if you hire a cab in New York City, in the real world, that order does not wait for somebody hiring a cab in San Francisco. They're two different contexts. But in today's technology, they are all forced in the same global ordering, but in a contextual model, they don't. Each can happen in parallel. Similarly, if I'm trading a token in a DEX, I should not be blocked from buying a coffee in Starbucks. fundamentally two different contexts. They don't need to get to the same queue. But in today's technology, they get into the same queue. But in real world, value transfer happens in contextual quasi boundaries. So in MOI, the participants bring the right context to each interaction. So your assets, preferences, and even the portions of the network which participate in your asset transfers are different for different interactions and different participants. So I can have multiple roles: ordering a cab in New York, making a token transfer, and booking my movie tickets, all of them at the same time as independent interactions. They are separately independent so that one doesn't block the other at all. So like in real world, you have roles, you can have multiple roles, which allows you to do truly parallel contextual interactions. And that kind of solves this global ordering problem, which is the fundamental reason why you have the challenges in blockchain, and that gets solved through contextual compute. So as I told, this allows for millions of independent contexts run in parallel. It's not millions of independent interactions, million contexts. So one participant could be in 100 contexts at the same time, and each one could have different preferences of security, privacy, trust, compliance, and that's the way real world operates, right? For example, an application which does data compliance in India could be using a bunch of nodes, which is totally different from another application, another user doing a data compliance applications in the US. So your ability to modulate the kind of network need based on your interaction context makes it work for real world. So simply put, hyperlocal finality, which means you get all the customizations of a local finality with global connectivity. So you can order your food or order a cab in New York while also doing a global transfer of your Bitcoin on the same network without losing fidelity or speed. So what does this all mean? This is like we believe contextual compute and the ability to have this non-globally ordered intelligent system is like the HTTP moment for the Internet of Value. It allows you intelligent composability. Participants become the fundamental fabric on which networks operate. So intelligence moves from one systems or one agent to another application through participants. So assets are safe, agents are trusted, and seamless integration of enterprises. So rather than just focusing on compute, which is what the first generation of blockchains did with smart contracts, we create a truly trust and interoperability layer for a million node economy. So think of it like before HTTP, you had intranets, and there were walled gardens all over the place. So the standard and allows you to manage information in an interoperable fashion. So with context, we will be able to do that, and that'll kind of open up everything to work in a safe and scalable manner. So this is all not theory. So we have been built this for the last 6 years of running networks. What can it solve today? Safe DeFi is the first starting point with stable coins becoming mainstream. One of the largest problems that Safe DeFi has is the shared contracts where assets get stored and lack of unified liquidity and needing bridges, which creates security issues. So we solve that problem with participant-centric assets. Assets that's not stored at the contract level, at a participant level. So that allows this new $17 trillion of traditional finance assets to come on chain. The second large opportunity that we have is trusted agentic AI. Agentic interactions are going to be almost 70 to 80% of all interactions by 2030. And the fundamental need for this is trust, the ability for the agent to have the entire view of a participant when accessing different parts of the network. We will be able to provide that. And the third one is enterprise integration. So one large problem today's enterprises face is all or nothing situations. So today, if I already have an ERP system, an SAP system, they will have to fundamentally move to blockchain to access the state management capabilities of blockchain. But with MOI, we don't have to do that. We can have on-demand trust. So you'll be able to run your compute in your existing ERP systems and then use blockchain for on-demand trust, like the way you're using a simple database. And finally, gaming, right? True asset ownership, seamless cross-platform economies. So with contextual compute and participant-centric design, we are fundamentally making Internet of Value work like real-world interactions, hyperlocal, compliant, flexible, scalable. And so it releases a lot of opportunities for real-world adoption of blockchain. So at a very high level, this is what we have done. And happy to take calls later on, but I would like the team to go ahead and talk a little bit more about how we did this and how people can get engaged. Thank you.
Thank you, AK. And now I would like to hand it over to Rahul, who will give us a little bit more about the tech updates.
Hi guys, I'm Rahul. I'm the lead developer here. So yeah, thanks Ananta for all the intro. Now let's get a bit more specifics into the engineering. So I'll just explain a bit more about context object and ordering. Yes, as Ananta brought up, we are a context-based protocol. Everything revolves in context. So let's understand what exactly and how exactly the context is represented, right? So the context of a participant is represented through the context object. It has 4 important dimensions: assets, files, logics, and trust. So assets is nothing but it gives you the entire assets held by the participant, and the files and the logics the participant has deployed or has interacted with. I'll give more specific details, the features that you guys can utilize to build unique applications on top of MOI, which are only possible on MOI protocol. And the final thing is trust. So you can even modulate your trust for every interaction. As Ananta brought up, it's about casual ordering, right? All human interactions are driven by context, and this context is basically ordered. What I mean by that, at the same, for example, I may be paying for a coffee. At the same point of time, I may be transferring some money to my friend, right? So both are 2 different contexts. And how do we do it is basically we create a dynamic consensus set for every context. And this is called as interaction context. And this involves context of different participants. The same participant can be in multiple interaction happening at the same point of time, right? So I can be buying a coffee at the same point of time. I can be paying something else, paying for my friend, right? So that is what you see on the picture out there. It's very small, but the blue circle out there is basically the interaction context, which includes the Alice context and Bob's context, and also some network entropy, right? And millions of these contexts can run in parallel, right? So that's the power of casual ordering with context. So yeah, that's about context object and casual ordering. Now I'll be talking more about the core features. This is one question people have been asking me for the last 5 years. You guys are building for a good amount of time. What exactly are you up to, right? So there are 6 important features that MOI protocol supports, right, or enables. The primary one would be native assets. So all the assets in MOI protocol are basically native. You get the same safety as your native asset, like in case Ethereum, it is ETH, right? So you don't really need to write any business logic or you don't really need to deploy ERC20 or ERC721 like logics to manage assets. All of these capabilities are natively available in the protocol. As of today, we support 3 to 4 standards, but the protocol is designed in a fashion to extend it over a period of time. So we welcome the community to keep on adding more and more asset logics based on the business requirements. The second important aspect is context inheritance, and this is the one which is basically allowing your ordering with context. The core ideology of context inheritance is the fact that a single participant can have different personas at the same point of time. For example, I'm a co-developer here at MOI Foundation. At the same point of time, I'm also a friend to my. I assume when I go back home, I'm basically a son to my mother, right? So humans behave differently based on their context, right? So in office, I'm different versus when I go out with my friend for playing something, I'm a different person, right? So MOI protocol allows you to bring this concept to this concept of real world onto the technology stack by allowing something called context inheritance. So how does it work is basically a participant can go inherit the context of a particular application. For example, assume every day you play a game for 3 hours, right? And all the assets which are associated with your game are available in the game's context, right? So you can inherit the context of the game. So your assets which are scoped to that particular game are available in that particular context only. And at the same point of time, you also have a different context, which is your office context or which is your house context, which will be having a different set of assets and it will be doing a different set of work, right? So you can have context scoped interactions and all of them can be executed in parallel, right? So that's the power of context inheritance. This is not your traditional shards or bridges or application specific chains. It's the same single chain. It's just the roles that the participant is taking for each and every individual interaction, right? So you don't have the bridging problem. You don't really need to bridge your assets from your app game chain to your regular chain, right? So you don't have the hassle of moving your assets around. Right? So it's a single unified chain. It's just that your assets are scoped according to the interactions, or your total values basically scoped according to the context of that particular interaction, right? So, and we have this fully implemented. It is available for developers to make use of it, right? So it is very easy. So you can make your end users to just inherit the context of the applications that they are using and go ahead, tada. You get the power of an app specific chain in the single uniform network, right? So that's very powerful, right? So you can tune your user experience according to the application, but user doesn't need to really worry about whether they need to move their assets to different app-specific chains. And the third thing is basically modulated trust. As Ananta brought up, every interaction in MOI is dynamic, right? It's dynamically handled through a consensus set, right? So for every interaction, you can technically modulate all the trust requirements, right? For example, if you're buying a coffee, it's a very low-value transaction, so you may not need too many number of confirmations from random people. Versus you buying a house, which is a high-value transaction where you may need multiple other people to give some confirmations, right? So this way, you can modulate the trust requirements for every interaction, which gives you more economically viable transactions, right? So you're willing to pay higher gas fees for a high-value transaction versus a low gas fees for a low-value transaction. And it is only possible in MOI because we use the contextual intelligence to basically allowing you to modulate your trust dynamically for every interaction, right? And the fourth important aspect, which Ananta brought up, is basically easy, seamless integration with Web 2 systems, right? How do you do this? Today, as Ananta said, the only way for you to integrate your Web 3 into Web 2 is basically writing your business logic in smart contracts. Whereas in our case, because of the core innovation that we have done, which is called as ISM, Interaction State Machine, it will allow you to develop and support multiple interaction ops, right? So what I mean by that, there are different classes of interaction types that we support. We have domain-specific interactions. For example, interactions for managing assets, interactions for managing AI-related agents, interactions for managing your technical supply chain systems, and for commerce as well. So you have different domains of interactions which can be used to integrate seamlessly with your Web 2 application. So think like this, these are just Lego blocks, right? For example, if you want to integrate more into your traditional ERP system, right? It's very simple. You appropriately pull up the interaction type and integrate with your existing app stack, right? It's that seamless, right? So it's pretty straightforward. You don't really need to write any business logic. You don't really need to program anything in Coco or the programming language that we support. So that's about the composable interactions. It easily allows you to integrate with existing Web 2 systems. And the fifth important aspect of core feature is basically actor scoped states. To all the DApp developers out there, right? You've been very used to maintain the state in the in your contracts, right? So, for example, today my DAI balance is just a program variable setting in DAI contract, right? Today in Ethereum or in most of the other Ethereum-like protocols, the state is always managed at the contract level, right? And now because of this reason, the contract becomes bottleneck because you need to log the contract for every transaction, technically, right? So this way, all the state of the participants is only held at the contract level. Whereas, as I mentioned earlier, every participant has its own context in MOI, a context object. So you can technically hold the state of the participant, which is associated with the logic at the participant level itself, right? For example, assume if I'm talking to an Uber contract, that the Uber contract writes the data back to Rahul's context object, right? So when I want to book a cab, I talk to the Uber contract, right? And the contract can just write the state back onto Rahul's account, basically Rahul's context object. So this way, you can make Uber contract stateless. Now, when you make a contract stateless, purely logical, it opens up a different set of possibilities. It gives you enormous amount of flexibility and performance, right? So million people can use the same Uber contract without attending any lock on the Uber contract. That's a real parallelism, right? So you can get to process millions of transactions or millions of interactions in the casual ordering of the respective contexts. So that's actor scoped states. So you have actor state and you also have logic state. And the developers can build their applications utilizing actor state and logic state as well. And the final important thing, the technology is great, but how do you make it economically viable, right? As Ananta brought up, our goal is to build a million node network, right? How do you make it more viable for people like you and me to join the network, right? Most of the proof of stake systems out there, or most of the Sybil resistant mechanisms out there, are very capital intensive, whether it is your computational resources or your economical resources. MOI has come up with something called proof of context, which takes participants' behavior and their previous reputation in the protocol as a Sybil resistance measure, along with their economical value. So this way, we are able to come up with a very reputation-based Sybil resistance measure, which will give equal opportunity for a lot of people. You don't really need to put up a lot of capital or a very specific hardware to be part of the network. And on this basis, we have democratized the costing mechanism. We have come up with a new tallying rule-based cost mechanism, which will make your transactions more affordable and more viable over a period of time, right? So we have dual costing model. We have storage costing separately, gas costing separately, compute costing separately, and the cost of each unit of storage and gas is decided at every epoch, and that through a democratic democratic voting among all the validators at that particular point of time, right? So this way, we have built a very sustainable network, which makes the total operating cost of your application viable over a period of time. So that's the final important feature. So, yeah. And as I told you, I'll just go a bit more detail into each and every core feature. So summary of native asset is you don't really need to write any business logic. I'll exactly show it through our Explorer. You just need to choose the appropriate standard. We have something called a create asset interaction on. So you just need to make an RPC call by choosing appropriate asset standard. So at this point, we support 4 asset standard: MAS0, MAS1, MAS2, and MAS3, fungible, non-fungible, security token, and dual token model. But it is fully extensible, and we welcome the community to start contributing here. If you feel like there's some important standard that you need to support at the core protocol level, it's very simple. You need to put a proposal, and we roll out the upgrade to the protocol supporting a new token standard. With this, basically, it's that simple for you to create and manage an asset. You don't need to write any ERC20 logic. You don't need to modify any logic out there, right? And it is safe because all the assets are managed at the participant level. Context inheritance, as I told you earlier, I spoke a bit about this. This is a very important feature of MOI, which is going to support context scoped operations. Your assets are scoped according to that particular context, which gives you enormous amount of scalability. At the same time, it creates seamless interoperability, right? Because technically you're in the same chain, just that your interactions are scoped according to that particular context that you're interacting with. So it gives you safety because your assets are scoped to that particular interaction. At the same point of time, it gives you performance because mutually exclusive context ordering, casual ordering of the context allows you to parallelly process multiple transactions. And the final thing is basically seamless interoperability, because when you want to move your asset from your game context to house context, it's just a straightforward transaction. You don't need to bridge across multiple app chains, or you don't need to move across a bridge or lock up in some bridge contracts as well. It's just a plain transaction, value transfer transaction that you do, right? The next one, modulated trust. So this basically you can fine tune the safety and performance. So it's always 0 or 1 in current day protocols. If you want performance, you need to compromise on safety, and vice versa. In our case, it's not like that. You can fine tune it for every interaction, because we firmly believe that each interaction has its own set of demands, right? So this way you can configure the safety measures, the performance measures for each and every interactions according to the business requirements. It's very powerful. It allows you to really build very sustainable applications on top of us. And the important aspect here is everything is instant finality. All transactions are processed in an instant finality model. You don't have any probabilistic finality model here. All the transactions are processed in a single slot. And composable interactions, as I told you, we have domain-specific interaction ops, and we'll be rolling out, my colleague will be talking about these SDKs later on, but we'll be rolling out domain-specific SDKs. So developers need to go figure out what SDK they are interested in and just integrate that SDK. We will be rolling out these SDKs across different languages. Currently, we're planning to start with JavaScript, but we'll be rolling them across JavaScript, Java, Python, Go, and other languages as well. The core ideology here is use the appropriate interaction type. Think like these interaction types as Lego blocks. Use the appropriate Lego block and construct your product out of it, right? So it's a plug and play interface. It's very easy for people. It's easy to integrate with existing Web2 systems. Yeah, so active scope state, as I mentioned earlier, it allows you to build true stateless logics, because the state is now held at the participant level. The logic is plain business rules. You can upgrade your logics. You have fine-grained access control at the participant level. So the participant can choose what data is allowed for contract access. So you don't have traditional attack vectors, which are possible today in stateful contracts like Ethereum and EVM. And yeah, we have separate pricing model for storage and compute. We have a new tallying rule-based price update mechanism at the end of every epoch. So this makes your pricing more generic, or I would say your pricing more real, because now you're charged separately for storage, you're charged separately for compute, and all these prices are updated every epoch. So you have, and it's a democratic measure, right? It's not something which is decided by the foundation. It is decided by the validators who come together every epoch to vote on these things. So you don't see too much volatility in your gas prices. All right, okay. So now, before I hand it over to my colleague Robert, who will be giving you a more detailed view of the SDKs and stuff, I would like to show a small demo.
Okay, let me stop screen sharing so you can give us the demo. Perfect.
All right. Okay. So I hope you can see my screen. All right. So if you head over to docs.MOI.Technology, you'll find, let me just go back. So this is our landing page for all your docs, all the material out there. So you have 3 sections. Build section is for developers who want to build on top of us. Guard section is for validators or guardians who want to join the network and provide the infrastructure. And learn is the generic platform. If anyone is interested to learn anything about MOI, this is the section. In build section, you have JSON RPC API documentation, WebSocket API documentation. You have a lot of tutorials, and we're improving it. They're in the very nascent stage. We're improving it. We'll be rolling out a lot of documentation updates by end of this month. So you have how to create an interaction, how to create and manage participants, how to create and manage an asset. I'll show a short demo of how easy it is to create an asset in MOI, and you can also have tutorials for basically creating and managing logics. You have different packages. We have our own serialization library. So all the utility packages are here. They are fairly documented. But yeah, we welcome the community feedback and improving this documentation as well over a period of time. Okay, and okay, this purpose of this call is to roll out a new DevNet, right? So we have a new DevNet and an Explorer for it. So you can access the Explorer at dev.voyage.moi.technology. So this is our Explorer at a high level. When you just log into this, you see interactions, you see tesseracts. And we also have a small playground. You can play around with assets and logics here. And you can also make all the RPC calls supported by the protocol. Okay, so do you see the playground? It supports all the interactions supported by the protocol, all the RPC methods supported by the protocol at this point of time. Before that, for the developers out there, so I've logged in with my IOME. You can also log in with your IOME account or basically perform with GitHub authentication as well. Once you get into settings, you will be able to create your API keys. Currently, this is free. You'll be able to make 10,000 requests per day. So you can create an API key and start using this API key to build your DApps. It's that straightforward. You don't need to download any third-party applications or tools. Everything is just packaged into a single thing. You get to our Explorer, you get every other information, like you get all the access, right? So now let's go ahead, and this is Asset Playground. It's very simple. If you see, there are a bunch of interaction types, as I told you. As I mentioned, we have domain-specific SDKs. Now the Asset Playground is all about assets. So we have 4 interaction ops at this point: create, burn, transfer, and mend. Let's go ahead and create it. So I want to create an asset called DevNet. Just put the symbol. I want to choose a standard. You should choose a standard, but you're not restricted just to these standards. If you wish to have your own standard, it's very simple. You can write a business logic and deploy it as an asset logic. Protocol will take care of it, right? And my colleague Robert will explain you how these things work and how easy it is to write a Coco program and utilize it, right? And now I need to just put some supply. So I'll just put some like supply, and I create an asset. So what's happening underneath by the time this transaction gets processed is very simple. Based on the standard that you have provided, what's happening underneath is basically, it's very simple. I'm just making an RPC call with all the given data. Okay, yeah, it got finalized. So if you see here, I've created an asset with DevNet and it's auto-minted, but you can turn off this auto-mint operation. You can mint it later. So it has taken some 2.3K MOI fuel and 556 for the mint feature. So let's go to my account and figure out whether the new DevNet asset is available in my account. As we told earlier, every asset you don't need to, assets are not managed at the contract level, or you don't need to write an ERC20 contract. Everything is at the participant level. So this is my ID, this is my address. I have 6 tesseracts. I'll go to my balances field. If you see here, there's DevNet, there's KMOI, and there's red, and I have this 100K as the balance out there. Now let's try transferring to some other person. Okay. Now I'm trying to transfer this asset, which is basically DevNet. I need to get a receiver address. So I'll go to my friend's receiver address. I'll quickly grab one. Oh, shit. Sorry. Thanks, Gokul. I know you're listening to this. Okay, so I go here. I put the receiver address and I put the asset ID, which is basically DevNet, and we'll put some amount, 555, something like that, and just initiate transfer. Now it will ask me to put my password to unlock the wallet. So I'll just put my password to unlock the wallet. Ta-da! Right now the transaction is getting processed. It's creating a transaction and doing it. So just to continue the conversation, what it does is basically an RPC call, right? So, and all these interaction ops are already provided. You can find the documentation here at docs.moi.technology. The transaction went through successfully. Let me just refresh this. Sorry, excuse that there's some issue with the WebSocket API, so I need to manually refresh this. We're fixing it. Okay, the transaction was successful. So let me just go back to Gokul's account. I hit the Explorer. Let me search for Gokul's participant ID. Okay. Now we click on Goku's balance. Yeah. Do you see this? There's something called DevNet, and you see 555 here. So this is it. This is it. It's very simple and pretty straightforward. So it's easy for you to just choose the appropriate asset standard and call create, and after that you can always operate on the appropriate methods available on each asset standard. It's completely extensible. This is this simple. Now I hand this over to my colleague, who will be explaining how to write complex business logics on MOI. Thank you.
Thank you very much, Rahul. Okay, I'll just share my screen. I'll try to fit into this 5 minutes. So first thing is, if right now Rahul has explained that everything can be done in Explorer. So if you're a developer and like to program, you can do some more things. We have SDK in JavaScript, and we are building new domain-specific interactions. So we will be able to provide like one-liners for almost everything you can do in MOI. And then we'll spend a few minutes on Cocoa programming language. That's the way how you can write your own logics, down to asset logic that controls assets. So if you're not happy with MAS 0, 1, 2, 3, we already have. You can write something completely different if you want. Still, you have to use asset engine. That remains. That part of safety is there. So if we go to JavaScript, so JavaScript SDK is something that just encapsulates all requests we are doing to MOI. So in SDK, we can like with minimal code create a new asset. We can use we can deploy logics that were written by something else. We can create new logics even, and so on. So let's say just for illustration, let's say in this SDK we have a class MAS 0 asset logic. And if we just use this class, we can create it with a single line assist, create, and so on. So this SDK takes away all the hassle with signing and everything. We just provide signer. We provide, we have a provider where you are sending this request, and that's it. And now for Cocoa, just as Ethereum has virtual machine EVM and Solidity language, MOI has PISA virtual machine and Cocoa language. Cocoa was designed to be very readable and understandable, and it's more similar to Python than to C or Rust. So it's indentation based, and the main thing why do we need Cocoa is it supports MOI concepts like context, that means different logic and actor storage, so participant storage versus storage that's in logic, supports native assets and stuff. But otherwise it looks like a pretty normal programming language. And with this Cocoa, we can write our own logics. We can create manifests, that just a YAML or JSON file that we can deploy to the blockchain, and it lives there and does whatever. So Cocoa has also a testing environment where you can try what your logic does. You can debug it, run it, whatever. It's called Cocoa Lab, but everything is in a single binary, so very simple to use. We have some documentation both for all SDKs. JavaScript has one, and Cocoa has its document. So we start from beginning, like how to write our first program and stuff. And we also have examples for Cocoa on GitHub. We have this Cocoa Lang example, so one can try to do something with it. So I'll just show a short demo how can we use these examples, and let's look at the example of assets. Right. So, okay, we just clone CocoaLang examples. We have few of them like Flipper, Counter, some ERC examples, but assets is something that's interesting for us. So if we look at how does actually an asset logic look like in Coco, here you see, if we look at the, endpoint transfer, like the first thing, is very simple. One is if events are enabled, it emits an event, so it tells what has happened, but all it does, it calls asset.transfer. That's a built-in native asset engine that's part of MOI protocol. So assets are first-class citizens in MOI. So the protocol knows about assets, and it has an engine that can handle them, and you can never access those data directly. So here for transfer, we basically just transfer some token that's in fungible token. It's just 0 from beneficiary to beneficiary, and it's always the sender who initiated the transfer is the sender. So that's, let's say, an example of our logic that's already deployed. Okay, so that's it, and we can write like everything we want, like things that read some data, transfers, mint, and so on. Now here we can take a look on how can we call this asset logic, because asset logic is something special. You never call, you never access assets directly. You can only handle assets through asset logic that is part of the logic. So when Rahul showed you that he had selected MAS 0, this is part of the asset and it will never change. That's it. So if you're doing your own logic, whatever, that uses this asset, you just have to introduce an interface to this asset. So here we have an interface. We just call it MS0 asset here. And we are going to use these methods like mint and burnt and maybe read symbol and balance off. If we don't need more of them, we don't. And here, let's say we can define our own mint in some very tricky way. Like we mint double the amount and then burn half just because we can do it. So we do this thing, and that's our own choice. So we are calling asset logic, and that's about it. So it's still, even if we are writing something of our own, it's still very simple. We are not talking about hundreds of lines of code for some simple operation. Now let's see how we do. So compiling these logics is really simple. Just issue Coco compiler, and that's it. Coco compile will compile from this Coco to a manifest that's in YAML by default, but it can be JSON or some binary format. And now we start our Coco Lab. So Coco Lab is a testing environment where we can actually test what we have written. So in Coco Lab, we first compile whatever manifests we have. So here we have use MAS0.YAML. So we will compile this logic. So now we get a real logic we can use and call. We also have to compile MAS0 just because Coco Lab has no connection to MOI, to actual net blockchain. So we really have to set up everything. So we create, let's say, two users, one called Robert, one called Rahul. Coco Lab is a bit easier. We don't need to copy paste too many 32-byte identifiers. We can deal with names. So if we have these users registered, we have this default sender, let's say Robert, and all we need to create asset is just call create MAS0 and then put some data in, some symbol, it's the manager, decimal supply and stuff. So same thing as Rahul has showed in the Explorer. And let's say we create an asset, we mint something, again, just invoke some one-liner, and then we can check what happened. So we have a bit more logs because because we have enabled events. Right. So and if we check what's the balance, now Robert has the balance of 1,000. Now let's try to transfer some of these assets to Rahul if we have if we have created it. Okay, so we check balance of Rahul is currently 0, and now we'll see. And now let's transfer some assets. So we are transferring like 100. We're transferring 100 units, and now we get Robert has balance 900, Rahul 100. And then let's just switch the sender. So now Rahul is doing something. So if Rahul transfers something to back to Robert, like 10, we can see Robert now has 910 and Rahul has 90. So we have this Coco app that can run anything, you can test everything, and then you can do it back. Again, you don't need to do it, but you can. So MOI, on one hand, just provides Lego blocks that 90% of users will just use, do it in Explorer. But if you're a real hardcore developer, you can basically do whatever you want with Coco and manifests that you can deploy as your own logics. Okay, that's it from me.
Okay, thank you so much, Robert. So now let me hand it over to Aditya, our dev role lead, and he is going to tell us a little bit more about what we are doing right now and how you can get involved.
Thank you, Ruta. Thank you, Robert. As Ananta and Rahul both mentioned, at the heart of everything we do at MOI is the participant, is the community. And I'm really excited to announce that we have plans in place to get the community involved in multiple different aspects. The first one being the university grant program, which is something that I'm personally leading. It's going to be a very quick 12-week program. We're going to be directly working with multiple universities in different cohorts. Each student group is going to receive a cash plus a token bounty, which is pretty exciting. I mean, the token launch is coming up soon as well, so there's a lot to be excited about there. But the best part, from my experience as a developer, the thing I would be most excited about here is actual one-to-one connection with the engineers. Obviously, Rahul, Robert, Gokul, and the rest of the engineering team have put in a lot of effort here, and it's for me personally, it's been a great learning opportunity, just working with them, talking with them, and for someone who's going to be a college student learning about MOI for the first time, getting one-to-one direct support from them is going to be a game-changing experience, which is honestly, from my perspective, the best part about this program. And as of right now, we have Purdue University, which is my alma mater, already involved. And we also have PCCOE, which is another university based in Pune, India, who are also part of the first cohort. And we have a lot of really, really interesting projects coming up. I mean, there are a lot of really talented developers in this space right now. And it's overall just a really, really exciting time for MOI, for crypto. And further, if anyone wants to get involved, wants to, talk to me or talk to any of the engineers about ideas or want to build on MOI, you can get in touch with me on Telegram. It's Aditya Ganesh 03. The QR code's also listed there. You could also join the MOI community channel, where we could also have a group discussion, a community discussion on best ways to maybe build a DEX on MOI. And finally, you can also join a Discord channel, which is probably the place developers want to be more than a Telegram group. And it's very, very exciting times ahead. And I can't wait to hear any of the ideas that the community brings up. And looking forward to this.
Okay, perfect. Thank you so much. I'm going to keep sharing my screen, but for some reason I can't turn my camera on with my screen shared. So Anyways, thank you guys for making time today. I know that we're working through a lot of different time zones and this might not have been as ideal as always, but we really appreciate you being here for this milestone of ours. If you are in Singapore, please reach out to anybody on the team. I'm sure we would love to grab a cup of coffee or even just get to know your opinions and thoughts. So please do reach out to us. We are in Singapore. If any of this sounds interesting to you, or if you would just like some free merch, reach out to us, either through our Telegram, our Discord, or even our X page. You can send a DM. And then last but not least, this video will be recorded and it will be posted on our YouTube channel shortly. I want to thank you all so much for taking the time out of your day to be here with us. Thank you so much. Have a great rest of your day, everybody.